Hello everyone. Today we are going to talk about kinematics, the review on the kinematics chapter. Let's get started. In kinematics chapter 1 of the AP Physics 1, we will talk about the motion. So everything is about motion. Stuff are moving around and we are going to discuss about those analysis that we have in this chapter. So let's get started. So we have four main formulas in this chapter. We're going to talk about them and we're going to talk about how to use them and when to use them. Many students ask me that, oh, I know all the formulas. They're very easy. I know them, but I just don't know how to use them. Well, that's exactly the purpose of this chapter. That's exactly what you need to know. So not knowing the formula, but know how and when to use them. Let's get started. The first equation that we have in kinematics chapter is that delta x is equals to vt. So the delta x is called as an displacement, v is called as an velocity, and the t is the time. Displacement is just basically when you change your location from somewhere to somewhere else. Imagine you're at the location of 3 meters and then you go to 8 meters like this. So how much is your displacement? Well, how much did you move? It's just 5 meters. So displacement is the x final minus x initial. I call them as an x2 minus x1 or sometimes x minus x0 as well. To make the video short, I'm going to talk fast. So if you need help, pause it, go back, rewind it, okay? So, but you need to understand every single thing that I'm talking about, otherwise it's not going to work, okay? So anyway, so this is the displacement, how much you're moving, okay? So displacement, which is delta x, is equals to the v as a velocity times the time. This is not a new formula. You guys have been using that forever. Think about it. The speed limit in a highway is like a 50 mile per hour. So what does that mean? It means that you can drive 50 miles in 1 hour. How much can you drive in 2 hours? 100 miles, 3 hours, 150 miles. This is exactly this formula. Look, displacement is a 50 times t. So 1 hour, 50, 2 hours, 100, 3 hours, 150. Piece of cake. Very, very simple. Okay. So this formula is very simple. And I agree with that, right? So it's a very easy equation that we have. But keep that in mind, there are a couple things that you need to pay attention. First of all is SI units. So the units that we use in AP Physics are SI unit, meaning that you have to use a meter, no like a kilometer, no miles, no feet, no inch and stuff. Everything should be meter for a length. The time is in second, no hour, no, I don't know, month or whatever, right? And the units that we have is here, right? So the meter per second, these are like mainly the one that we use in this chapter, okay? Kilogram stuff, next chapter, talk about them, okay? So you have to use the right unit for it. So the delta x is equals to VT. So the x is gonna be meter. The time is in second. As a result, the unit for velocity is gonna be what? It's just going to be meter per second if you divide it like that. Make sense? So that's basically the equation that we get, and that's how we calculate the unit for the elements that we have. So the velocity is meter per second, x is in meter, and the t is the time, which is in second. Very simple. So let's move on. Let's do a very easy example and then move on. So like, for example, imagine that you're driving at 30 meter per second for 10 seconds. How much you're driving? The delta x is equals to vt. So the delta x is equals to v, which is 30 times 10 seconds. The answer is going to be 300 meters. Done. Piece of cake. So this formula is very easy. X equals to vt. It's very easy, but it is not very useful. Why not? Because this formula only works, right? So you can only use this formula when the v is a constant, which is pretty much never, right? Think about when you go from home to school. You go, you start from the rest, you start moving, go faster, go slower, red light, you stop, go faster, get a ticket, and then move on and stuff like that, right? It's very rare to move with a constant velocity. As a result, this formula cannot be used for many of the problems. So we need a second formula. What is the second formula? First of all, is a definition of what happened when the velocity is changing. Is going to be acceleration. Acceleration is the delta v over the t. It means that like how fast the velocity is changing. Is basically the change of the velocity divided by time. You know that I can just rewrite this formula as an delta v is equals to at as well, right? Same formula. It's just I wanted to kind of look like the first formula. You see, delta x equals to vt, delta v equals to at, right? So the acceleration, basically the unit is like this. This is meter per second. This is second. So the acceleration would be meter per second squared. There we go. Very simple. Okay. So meter per second squared is the unit for acceleration. But what exactly the acceleration is? Acceleration is the rate of a velocity. It just means that how fast you can get fast. Make sense? It's like basically how quick you can get fast. Like think about it. I'll give you an example. Imagine you're waiting at the red light and then suddenly next to you there's like a Lamborghini come next to you, right? As soon as the light turns green, you guys are gonna start racing. So what would happen is that in the 3 seconds, you see that the guy disappears, right? Why? Because the car is fast. No, it's because the car have a high acceleration, not because it's fast. So eventually he's gonna get to like a 50 meter per second, which is the speed limit on the street, but you're gonna get to the 50 meter per second eventually as well, which is a speed limit, right? But he's gonna get there in like let's say 3 seconds, you're gonna get there in 12 seconds. That is the definition of acceleration. Like how quick you can get fast. And that's what the acceleration is, right? So don't get confused between how fast something is. Fast means speed, right? But acceleration is that how quick you can get fast, right? Like an airplane has a high acceleration because in 3 5 seconds, it's going to get like, I don't know, like 300 mile per hour or something, right? So anyway, that's just a definition of the acceleration. Okay. Anyway, so we learned two formulas so far. The delta x is equals to vt. We said this is useless. We said delta v is equals to at. We said this is cool and stuff. But the second one is also missing something. What is it missing? X. If I ask you for displacement, you can't use it. You can't solve it, right? So that is why that you need the third formula in this chapter. The third formula in this chapter is that delta x is equals to 1/2 at squared plus v0t. This formula came from here actually, but you need to know calculus to know where it's coming from. But anyway, for now, just memorize it. The formula is very simple. This is delta x is the displacement, acceleration time, initial velocity time. That's it. So that's how you can calculate the displacement. Let's do an example and then we move on. So imagine you start from rest on the red light and you start moving. And after, let's just say like a 5 second, you get to the velocity of 40 meter per second. Make sense? So you start from rest, you start going faster, faster, faster. After 5 seconds, you get to 40 meter per second. So now the question is asking that, how much is this displacement? How much is that? Many students make a mistake and said that, oh, that's easy. The delta x is equals to vt, and said that, okay, the delta x is equals to v, which is 40 times 5 seconds, and it's going to be like 200. Yay, that's wrong. Why? Because your velocity is not 40. Your velocity is 40 at the end, is not 40 the whole time. You go from the rest, you go faster, you go faster, you go faster. So your velocity keeps changing, which means that this is not legal to use this formula if your velocity is changing. Make sense? So again, the first formula can be only used if the a is 0 or the velocity is a constant. You cannot use it anytime you want. You can only use it when the velocity is constant. If it's not constant, you have to use this formula. So let's use that. So first of all, I need to calculate my acceleration. We know that the acceleration is the change of velocity. So the 40 minus 0 divided by the time, which is 5. So it's going to be 8 meter per second squared. Make sense? So that's the acceleration. And then I'm going to use the formula. The delta x is equal to 1/2 at2 plus v0t. So the displacement is equal to 1/2 a, which is 8, t, which was 5, which is 25, plus initial velocity is 0 because you start from rest, right? Times 5. And then you just calculate it 4, and the answer is going to be 100 meter. Very simple. I suggest you pause the video, go back and redo the problem one more time, okay? Again, I'm talking fast because I don't want to like create like a 5-hour video, okay? So I hope you don't have any questions, but if you have any questions, just let me know. So, all right, moving on. So we talked about the third formula. We said that, oh, that's very good. So you can take care of a lot of problems. Now, let's talk about a couple of challenging questions that usually show up in the A/B test, and you need to know them, right? So imagine that you're driving in a highway with a speed of like a 40 meter per second, and then you slow down your speed because you're going pretty fast to, let's just say, 10 meter per second. This whole process takes like 8 seconds, for example, right? Or like 3 seconds, let's say. It takes 3 seconds. I want to know that how long does it take? Like, how far are you going to travel during this whole process? You're going at 40, you start applying a brake, you're just going to go slow, slow, slow until you reach to the 10. The whole process takes very quick, 3 seconds. I want to know that how much are you going to move here? Okay. So what is very important for you to understand in this chapter is that try to write down the variables that you have. What is this? This is your V initial, is 40. What is that? That is your V final, which is 10. What is this? This is the time, which is 3 seconds. Do you have acceleration? No, you don't have acceleration. Do you have displacement? Yo, you don't have it. Make sense? So that's why that you need to know what you have and what you're looking for. Now, keep this in mind in this chapter. Acceleration plays an important role. Why? Because in every equation you have, there's an acceleration in it. You see, there's a in there, in there. In the next formula, there's acceleration. So it plays an important role. So you most likely need to find it the first thing, okay? So the acceleration is going to be what? It's going to be final velocity minus initial. Look, A is equal to delta V divided by T. Final minus initial divided by 3, and it's going to be negative blah, 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 negative 10 meter per second square. The acceleration is negative, meaning that you are decelerating, not accelerating. You're like slowing down, right? So the rest is very easy. The delta x is equal to the 1/2 a, and then t squared, which is 3 seconds square, plus v0, which is 40 times 3 seconds. Solve it, you get the answer. Done. Easy peasy. So again, I hope you don't have any questions. If you have questions, go back and slow down the video so you understand them. So make sure you understand every single thing. If you don't understand it, go back, keep reviewing. You will get it eventually, okay? So don't just move on, okay? So, all right. So we talked about a couple problems. It's a time to talk about the fourth formula. The fourth formula is called as a time independent formula. The formula is like this: v2 minus v naught squared equals to 2a delta x. So the v squared minus v0 squared equals to 2a delta x. Remember that. My students always ask me that, oh, are these formula given? No, you have to memorize them, okay? So if you want to get a 5 in AP test, you have to memorize every single formula in this chapter. Don't be like dependent on any formula sheet and stuff, okay? Memorize. It's not that bad, okay? So v squared minus v naught squared is equal to 2a delta x is your time independent. Why is it called time independent? Because there's no time in it. So when do we use this formula? We use it when the problem is not asking for time, you don't care about time, the time is not given, stuff like that. It's called time independent. You see? So you have 4 important formula. Let me just like wrap them up, like review all of them. So the delta x is equals to vt. So this formula is very simple, but you can only use it when a is equals to 0 or the v is constant. First formula. The second formula is the delta v is equals to at. This is a great formula, but there is no x in it. Make sense? And the third formula is that delta x is equals to 1/2 at2 plus v0t. That is a great formula, but there is something wrong with it. I usually call this as an ugly formula. Why? Because it's ugly, right? So why we don't like ugly stuff is just because that, this is like a non-linear equation. Non-linearity is not fun. Why not? You may end up with quadratic formula. Who likes quadratic formula? In like 15 years of teaching, I never had a single student say that, oh, I love quadratic formula. Nobody likes it, right? That's why, right? You may end up using quadratic formula here. You will see the problems later on, okay? And the fourth formula is the v2 minus v naught squared is equals to 2a delta x, okay? So that is a time independent when you don't care about the time and stuff. I'm going to go back to the previous problem that we did earlier. So you have a car is going at like 40 meter per second, and then it's going to slow down into 10 meter per second. This whole thing is going to take about, I don't remember what I said, 3 seconds, and was asking for delta x. We calculate the acceleration as -10. We show that, right? I want to use a fourth formula in here. So the v squared minus initial velocity squared is the 2 times this times delta x. I'm going to use it differently. I want to solve it differently. So you get 100 minus 1600 is -20 delta x. And boom, you get the delta x from here. Very simple. My point is that this is a great thing that you have. You can solve the problem from different ways, right? So, but here's the thing. Sometimes you pick a wrong way, not the wrong way, maybe the hard way. So it takes you more time to do it. Make sense? So picking the right formula is extremely important. Okay. Here is a strategy that I always teach my students for this kinematics chapter. Step number one, always list the things you have and the things you're looking for. Like the previous problem that we did together, I said that, oh, I have initial velocity, I have this, I have that, and stuff. This is very important. Secondly, write down all four formulas you have exactly the way I did up in here. Write them down. For the first 2 weeks, definitely do that, right? Write them down, what you have, what you're looking for. Step number three is to pick a good formula. What is a good formula? A good formula that is like a formula that everything is given, basically everything you have it, but there's only one unknown in it. If you have like a formula like, oh, delta V is equals to AT, the V final minus 20 is equals to the A times 5, there are two unknowns here. There's no way you can use this formula to solve the problem. So it means that you picked the wrong formula. So go back and see, based on the things you have and the things that you're looking for, which equation is the best. Okay. This is the basics of 1D kinematics. Okay. We just talked about it. We talked about the formulas. So in a separate video, probably I'm going to like upload going over several questions. A couple of the questions that is going to be in the AP test. So I would suggest you to go over the stuff that I just said several times, right? And be ready for the next video to just do a couple problems together. Okay. All right. So I hope to see you later on. Okay.